Okay, so this afternoon we're going to be doing our combined gas equation, as you just heard. I didn't touch on any of the equations before because we can combine all of the laws, our three laws, which are pressure, Charles and Boyle's, into one equation. So let's look at our equation. Remember, I told you that we have three quantities that we're always concerned with. When it comes to gas laws, we have pressure, volume, and temperature. And we can put those three of them in one equation that states PV over T is a constant. What this means, as in for every given situation, as in a particular question, as in that particular question, if I divide the P by, multiply the P by the V and then divide by the T, I'm going to get generally a constant value. Just like how we've done several things like this. We've done momentum where before momentum is equal to after momentum, if you remember that, where before clockwise movements is equal to anti-clockwise movements. Similarly for here, all right, our pressure by volume divided by temperature is a constant value, where we can expand this equation to give us, I'm just expand a little bit, right, where I have PV, P1, V1 over T1 is equal to P2, V2 over T2. Why we have two different set of numbers? Because usually I will have an initial state of my gas. My gas will exist in some state. I have a volume of gas at a certain temperature and pressure. I can do something to my gas, and now I am going to have different values after I have done something to my gas. What is that thing I can do to my gas? There's several things. We can heat up a gas, we can cool down a gas, we can compress a gas, we could expand it, or we could apply pressure or take off pressure. And by changing those three points, which are P, V, and T, we can change how a gas behaves. So this is why we have an initial state, which is P1, V1, T1 is our initial state. We do something to our gas, and then we end up with a final state, which will give us P2, V2, T2. All right, so that's why we end up with just the different numbers for your letters. So let's read from the screen. Really can't fit? All right, so let's read from our screen. The combined gas equation, like the gas laws, will only work if SI units are used for each quantity. So when I speak about SI units, pressure, volume, temperature, pressure must always be in pascals. Volume must always be in meters cubed, and temperature must always be in Kelvin. We did go through again and again our conversion units. Now, sometimes you're going to get your pressures in atmospheres, and it's okay to use atmospheres if you're only working with atmospheres. But if you have pascals and atmospheres, you need to go and do some conversions. But we'll cross that bridge when we reach it. So let's continue reading. The combined gas equation assumes an ideal gas. What is an ideal gas? An ideal gas is one where the gas molecules move randomly and do not interact with each other. We live in a real world. Nothing around us is ideal. The closest to ideal that we have on this planet is a transformer. That's the closest ideal thing that we have anywhere. But everything else, things affect them. Impurities affect AF, right? Affect how systems work. Ambient temperatures, meaning the surrounding temperatures, affect how systems work. So we can't use ideal situation equations for real world situations. But being that this is CSEC and life is nice and simple at CSEC, trust me, it is simple at CSEC, right? We use idealized situations. We use ideal gases. We use ideal equations because, trust me, this equation, when you see what it's supposed to look like in engineering, it's like 40 terms, and not 40 terms, but a whole bunch of terms and things to add and subtract. So we use an ideal gas, and you all should know what an ideal gas is. An ideal gas is one where the gas molecules move about randomly and do not interact with each other. That doesn't happen in real world because Our gases are combinations of gases. Air is a combination of gas. We have nitrogen, oxygen, carbon dioxide, water vapor, and a whole bunch of other inert gases and greenhouse gases in it. So we don't have ideal gases, but for our questions, for the sake of our questions, we assume that they are ideal. So there's no reason to bring up any other topics, any other points, or whatnot. So let's continue reading. There is no gas that can be considered to be ideal, but the closest we can get, the nearest, most ideal gas that we have experience with is hydrogen. All right, hydrogen is the closest that we have. Why hydrogen is considered to be an ideal gas? Because hydrogen molecules really and truly do move around randomly. They do not interact with other molecules because hydrogen sticks together. That's why we end up having massive clouds of hydrogen gas out in space. All right, those are the building blocks of nebulas and stars and whatnot. All right, so hydrogen is the closest that we can get to a perfect gas. Other gases, not really. But for the sake of calculations, we consider all our gases to be ideal. As in, it's close enough, so it's not really for us to bother. All right, so for you to do, you must be able to explain how the three gas laws work according to the kinetic theory of matter. What is the kinetic theory of matter? Again, one, all matter are made up of small molecules, and these molecules are always in motion. So for you all, I do suggest you write it down, explain how pressure law works according to the kinetic theory. I did go through it with you all in depth already, how Charles' law works and how Boyle's law works according to kinetic theory. You must be able to do it. I actually was looking through some past papers just now, and I did see it several times where they asked you to explain how these laws work according to kinetic theory. So please go and give it a write. Don't just sing, yeah, huh? You need to go and write it down, sit down and think about it. If you want to send me it and see if you got it right or you had the proper concept, that's fine. Start sending your questions my way, start sending your revision my way. Anything you want me to explain, start sending them because that's what we're going to start doing after next week or from next week actually. So let me hit a pause because I need to change the handout. So we have another handout on the screen. So we have here our next handout, which is gas laws and how to do their questions. All right, so how to do their questions. Sorry. All right. We just have to take in consideration a few rules when we're doing gas law questions. So let's read. There is always an event that leads to the change in our gas. Remember, I just went through that. We can either heat our gas, cool it down, we can pressurize our gas, we can increase or decrease the pressure, or we can change the volume of our gas. We can expand it or we can compress it, right? So there is always an event. You all have to learn to read your question and determine where our event lies. So let's continue reading. We have to be able to identify for initial and final values when working with these questions. So just as I said, P1, V1, T1 are your initial values and P2, V2, T2 are your final values. So that means somewhere in the middle here, there is an event. Don't worry, the event is easy. It's a verb. I think we could identify verbs. So it is helpful to list all your terms at the start of the question. Folks, I do this up to today. I have done thousands of heat questions, gas law questions in my lifetime, and I still do this up to today. All right, I don't think I can show you the notepad because it's not showing up on the screen, but probably if I can get the camera. Right, not working with the backdrop, but you can see I always write my P1, V1, T1 and P2, V2, T2. So the first thing you all do, very first thing you all do when you're doing these questions, you write down your values. So that's put in, if that's your page, right? You do your P1, V1, T1, hit a equal, and then the next column away, P2, V2, T2, hit your equal sign. Trust me, the calculations are usually not the problem in this topic. The hardest part is the English language, right? and sorting out the values that you've been given. If your English language, you don't read what you get, or you don't pull the right information from your questions, and you don't list them out properly, you are going to get confused. You're going to make mistakes. All right, remember, I keep telling you all, we were students too. We went through the same problem as you all, right? And we're coming from experience and not just like, oh, Miss, you're a teacher, you know everything. No, I don't know everything. I try to know everything. That's why I learn more every day. But we're just giving you the tips that helped us and that we've seen over the years that helps in doing these questions. So don't try to do these questions mentally. Please don't write down all your values. I'm asking and begging you. It takes 1 minute to write down your values. Not 1 minute, 30 seconds to write down your values. So let's continue reading. Where's my marker? Okay. All right. When it comes to dealing with gas questions, wording is extremely important. As I just said, the English language is probably sometimes the hardest part of these questions. Not the calculation. All we're doing here is multiplying and dividing. Ain't hard. Right?
Right?
Okay. All right. So wording is extremely important in determining how, oh, sorry, and how you should proceed with these questions. Some tips to note. Please note the tips, folks. All right. One, whenever a quantity is to be held constant, we take it out of the equation. You're going to see when we're doing it just now. All right. So this is just a little help. You're all ready for exams. Your algebra should be top notch by now, so we can run through this without having to be, suffering too much. So suppose I have P1, V1, T1. I have P2, V2, T2. And I said that my volume is constant. So let's say that the volume is equal to 2. The volume is constant. So that means in my question, my volume is not changing. So if you want, you could go and put this down. V1 is 2 and V2 is also 2. Let's put it into our equation. We're going to see why we take out terms that are held constant. So I have P1 V1 over T1 is equal to P2 V2 over T2. And here we see that V1 and V2 are equal, and that's equal to 2. So I'm going to get 2P1 over T1 is equal to 2P2 over T2. Y'all, and when we have a number that's the same on both sides of the equal sign, we can cancel it out. Yeah, we know that, right? It's some basic algebra, right? Really basic algebra, and I trust you all are ready for exams. Your maths is proper. You all can do that without going like, what? All right, so the twos will cancel. And look what we end up with now. We're going to end up with P1 over T1 is equal to P2 over T2. Isn't that the same thing as saying if I had started my equation and I said that V is constant, all you have to do is to take it out of the equation. So it makes life easy, right? Whenever when a quantity is being held constant, all you have to do is take it out of the equation. Write down the equation first. Write it down. Always write down the equation first. And then you take out what you need to take out and you work as you go. All right, so that's tip number 1. Sounds a little bit confusing now, but once you start doing questions, it's like, yeah, miss, that make real sense. All right, because if you have the same number on both sides, it can cancel. And by canceling, we've taken it out. These are just tips that you may come across or tips that will help for questions. Volume is constant, meaning our volume will not change in the question when we say the gas is sealed in a container or a canister. All right, particularly if it's in a steel canister or steel tank or within a tank. This is the hidden meaning of that question. If I say I have a gas contained in a steel tank, that means that that steel tank is unlikely to be expanded by the gas. So our volume of the air or whatever our gas is not going to change. So we take that to mean that the volume of the gas is constant. What does that mean? When we come to the equation, we end up just taking it out of the equation. So you see how sometimes the wording gives us information, right? Not all our information are going to come as words. Some of time you have to read, or as I call it, mind the equation, mind the question to find what they are telling us. So when something is in a sealed container, volume is not changing. Remember that. Question part 3. This is where we use a little bit of maths, but you all, as I said, you're all ready to go for exams, so you will understand this very easily. When you are given a percentage change for volume or temperature, it will be necessary to use the smallest bit, the smallest bit of algebra in the meantime. Example, suppose I gave you a question, I said that the volume increased by 20%. I did not tell you what the volume was. I said nothing about the volume value, but I did say that the volume increased by 20%. I can use that number to calculate. Let's see how we can use that situation to calculate. Even though they did not tell us the original volume, we can use a substitution because let's make a substitution of our V1 being equal to V. We're just making a substitution. This is what algebra is. Algebra is using a letter in the term in place of an unknown number. We don't know the volume value, but we're still working with it. So if I said that my initial volume is V and it said it increased by 20%, right? That's going to mean that our V2 is 1.2 by V. How did we get 1.2? Let's check it and see. A whole number is 100%. You all should know how to do percentages by now. I trust you all do know how to do percentages by now, right? One of anything, 1V is equal to 100% of V. We know that. That's how we get percentages. We multiply our decimal by 100%. So 1 of anything is 100% of that value. An increase of 20% means that we have an additional 20%. Increase means to get larger by, or to add a different number, or to add a further number. So that means we have now added an extra 20%, or if you want decimals, an extra 0.2, right? Because you all should know, honestly, right? 20% and 0.2 is the same number. Hence, given us V2 is equal to 120% of V1, of V, or 1.2. Don't worry, the V's, even though you all see a V here, these V's will cancel each other. We're going to go do questions with the unknown, so you're going to see how they're going to cancel each other. So a little tip, anytime you all see a volume or pressure increase by a percentage, all you need to do is just add it to your decimals and introduce an unknown term, and it's going to work out as the best little term. Suppose, let's think of a little idea, putting you all on the spot. Suppose my next example, suppose my pressure increased by 50%. What will my P2 be? If my P1 is equal to P, my P2 will be equal to how much? Using the same logic. You could put it in the chat or you could see it.
It's 1.5?
1.5. Very good. 1.5p. And now we have two numbers we can work with. The p's are going to cancel when we have to multiply and divide. And you see that's all we're going to get. Let's try the next one. 150%, that's correct. Yeah, 150% is correct, but we don't use 150% in calculations. When we have to use percentage in calculations, we need to break it down into a decimal. So 150 is correct, but we can't use that for calculating. Let me give you a next one. Let's try one more. Suppose I said that the volume, a little twister, let me give you a little twister. So suppose I said the volume decreased by 15%. If my V1 is equal to V, what is my V2 going to be equal to? Let me see who can get this. How much?
0.85.
You see, I tell you, you're ready for exams. So the brain's clicking and tucking. Very good. It'll be 0.85. What does decrease mean? Decrease means to get smaller. So that means we're going to have 100% minus 15%. So that's going to give us 85% of our value. Of course, we don't use percentage in calculations. We have to convert it to decimal. And 85% is 0.85. So really good. That's good. Let's continue reading. These are just little tips and stuff that I come across questions quite often. So I'm just trying to cover as many things as possible beforehand here. Please note, increased from is very different to increase by. These means two very different things. These words of from and by indicate two different meanings. So I don't want you all to get catch all. Let's see the word increase and then do nonsense. When I say increase from means that you're starting from one value and you're increasing to another value. So let's give an example. Say I increased from 10 degrees Celsius to 20 degrees Celsius. Increase from means that we have a starting point and an ending point. That's usually what we mean when we indicate increased from or expanded from or pressurized, from one point to another. That's what from indicates, that we are going to get two numbers. By, when I say something increased by, that means I am telling you how much to add to your number. So let's check and see the English. So if I said it increased by 5 degrees, suppose my temperature was 10 degrees Celsius. My original temperature was 10 degrees Celsius, and I said that my gas temperature increased by 5 degrees. What is my new temperature going to be? Y'all, that's really simple. Increase by means how much I increased our number by. Increase by means to add. So if I said I increased by 5 degrees Celsius, 15, very good, Isis, right? That means my new temperature will be 15. So please note, increase by usually means I am adding or subtracting a number. So suppose I had said decrease by 5. Decrease means I went lower by 5. So you all see how English language is our biggest enemy, particularly in this topic. And lastly, most importantly, I've been singing this for 2 years. Always work with SI units. Always, 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 folks. Right? As in our volume must be in meters cube. Our pressure must be in pascals. Now you can use atmospheres, since you all know what atmospheres are. Sometimes you can use atmospheres. And our temperature must always, always, always be in Kelvin. If you use Celsius, there's no way your question is going to be right once you have to use temperature to calculate. So get your calculators out. I hope you have your calculators nearby, because we're going to be doing some quickly, not the first one, but the others, because we can't take too much time to get this done. So let's see what we have. Let's get some working space on our screen. All right, so this is what we're going to do. I'm going to show you how to do part A. I'll pause the recording, and you all are going to do part B. All right, I'm not going to leave anybody. Well, I hope I leave no one behind. I hope that everybody gives them a try. It's for your own good. All right, so let's read our first question. Get a little closer. Right. A steel canister has 0.05 meter cubes of gas. When this gas is at 10 degrees Celsius, it has a pressure of 1 by 10 to the 5 pascals. Calculate its new pressure if the gas is heated to A, 50 degrees Celsius, and B, 130 degrees Celsius. So, very first thing before we do anything in our questions, we write down P1, V1, T1, and then we're going to put on P2, V2, T2. Let's start mining our questions. We say that a steel canister has 50.05 meters cube of gas. What did I say about a steel canister again? When something is in a steel canister, that means that the volume is not going to change. So our volume is going to be held constant. So if my initial volume of gas was 0.05 meters cube, guess what? My final volume is also going to be 0.505 meters cube. Let's read our next one. All right, so it has 0.05 meters cube of gas. When this gas is at 10 degrees Celsius, it has a pressure of 1 by 10 to the 5 pascals. So that means pressure is 1 by 10 to the 5 because pressure is measured in pascals, and the temperature is 10 degrees Celsius. Right away, I have the habit of, as soon as I see Celsius, I convert it to Kelvin, whether I'm going to need it or not. Right? It's just a habit. And how do we convert Celsius to Kelvin? We add 273. So you're going to get 283. Let's read the rest. All right, calculate the new pressure. So what we want to work out, we want to work out P. When part A, our new temperature is 50 degrees Celsius. So our new temperature is now 50 degrees Celsius. We convert it to Kelvin one time. And that's going to give us 323. Hold on. All right. 323. So we have all numbers. Let's put it in our equation, see what we're going to get. All right. So we're going to have P1 V1 over T1 is equal to P2 V2 over T2. Now we did say anytime something is held constant, and we can see our volume is constant, so they're going to cancel out each other. You know what? We can just take this out. So go and rewrite it, and I'm going to put P1 over T1 is equal to P2 over T2. Let's see what we have. We have P1, yeah, we have T1, we have T2, and we just want to find P2. So we have all the values we need to work out what we have. As a math student, or some of you like maths, I like to play around with the equation first and then plug in my values. If you all want to go ahead and put the numbers in first and work as you go, ain't nothing wrong with that at all. I just like to work with algebra, right? So what I would do, I would make P the subject of formula. What you do, you cross multiply. So I'm going to get P2 by T1. You all know how to cross multiply, right? And then you cross multiply again. So you're going to get P2 by T1 is equal to P1 by T2. And how do I get P2 on one side of the equal sign? I just divide by the other term. So I'm going to get P1 over T2 is equal to T1. So what I do now, I plug in all my values. Personally, why I like to use the algebra first, because I will make less mistakes. Because suppose you write down this value wrong somewhere, right? You can make mistakes in putting in your values, especially when you have decimal points to work with. So I rather put all my letters on one side, get everybody arranged, and then I start plugging in numbers. But if you want to go ahead and work, y'all, nothing, absolutely nothing is wrong with it as long as you do it correctly. What works for you works for you. All right, so let's plug in our values. So I'm going to have P1 is equal to 1 by 10 to the 5 multiplied by T2 is 323 over T1, and T1 is 283. And when I work that out, I'm going to end up getting 1.14 by 10 to the 5 pascals. So let's go through that again. Let me just scroll on this side of the screen. Get a little bit smaller so you can follow the steps. So let's take out all the extra writing. Let's follow it straight through because you all are going to do the next one on your own. You're going to do 130 on your own. So let's follow these steps one by one and really quickly. All right, that's taking out all the extra stuff. So reading your question, this is how you do it fast without me pausing and explaining in the middle. A steel canister has a volume of 0.05 meters cubed. When the gas is at 10 degrees Celsius, it has a pressure of 1 by 10 to the 5 pascals. Calculate its new pressure if the gas is heated. So you're not heated is our verb. Heated is our event. So this is where we get something happening afterwards. So they've asked for the new pressure. So that means they want to find out what P is, considering we have two new temperatures. So let's plug in our values. P1, P1, V1, T1, P2, V2, T2. Mind our questions. Let's get go. Right? They said that our volume is constant. Why is our volume constant? Because it's in a steel canister. The steel canister indicates, implies that our volume is not changing, so our volume remains constant. All right, so our V1 is going to be equal to our V2. We said when the gas is 10 degrees Celsius, it has a pressure of 10 to the 5. Calculate the new pressure. So that means we want to work out what the new pressure is when we have a temperature of 50 degrees. So 50 degrees, I convert both of these into Kelvin. So let's plug and see. All right, so what we have P1 V1 T1 is equal to P2 V2 T2. We said that the volume is constant in this question. We do see that the volume is constant in this question. So make life easy and just take it out. Rewrite it and take it out since V is constant. And you're going to end up with P1 over T1 is equal to P2 over T2. I manipulate this formula to make P2 the subject of the formula. And I'm going to get P1 T2 over T1 is equal to my new pressure. What is P1? 1 by 10 to the 5. What is T2? 323, I'm sorry. And what is T1? 238. Multiply your numbers, you're going to get it. If you want to just plug in your numbers from here and work with it, let me try that and see. So if I have, let's use our next color. So I have P1. Seriously, screen? Why are you doing that? So I have P1 over T1 is equal to P2 over T2. Let's plug in our values. P1 is equal to 1 by 10 to the 5. T1 is 283. P2 is what we don't know. And T2 is 323. 323. And we just cross multiply and divide. So you're going to end up getting P2 is equal, you cross multiply in here. All right, so you're going to get 3, 2, 3 multiplied by 1 by 10 to the 5 divided by your 283, and you end up at 1.14. Please put your values to two decimal places at all time. Don't round these off too extremely because you're going to end up getting a mistake. All right, by 10 to the 5. So following that method, we're going to pause right now. I'm going to give you like 2 minutes, 3 minutes to work out our new pressure when the temperature is 130 degrees. So what I would do if I were you, I would clean this up, right? Clean this up, write over new values. Well, our initial terms are the same. All right. So that's what I would do if I were you. All right. And then I would start putting in my values and go ahead and work. So you're going to pause. If you want to give me your answer beforehand, I already have it worked out. Go ahead and do that. So let's pause and you'll take about 3 minutes to work it out. So let's try the solution for this. All right, suppose I have my new temperature is 130 degrees. Let's go into our values here. Let's clear up our board, erase our board, start up nice and neat. All right, so they want to work out the new pressure concerning the volume is constant and the new temperature is 130 degrees or 403 Kelvin. So you're going to put these values into our equation. So let's work and see. Go real fast. All right, I had used before P2 is equal to P1 T2 over T1. plug in our values. P1 is equal to 1 by 10 to the 5, multiplied by T2, which is 403, divided by 283. And you're going to end up getting 1.42 by 10 to the 5 pascals. I hope those of you all who tried it got it. All right, so you just have to multiply across in your calculator. And let's go on to the next one. Everybody okay with that, or they want me to go through it again? Going on. Question 2, example 2. A gas has a volume, let's read our question. A gas has a volume of 0.0045 meters cube, a pressure of 50 kilopascals, and a temperature of 0 degrees Celsius. Determine A, the new volume if the gas is heated at 27 degrees Celsius and the pressure rises to 60 kilopascals. So the nice about these, nobody here, all of these 3 parts here are very different questions. It does take different parts of your formula. So let's look. First thing you do, P1, V1, T1, this is for A. P2, V2, T2. So let's see what we have. All our initial values are the same. So it has a volume of 0.0045. It has a pressure of 50 kilopascals. Kilo means to multiply by 1,000. So it's going to be 50 by 10 to the 3. That's what kilo means. Kilo means 1,000 or by 10 to the 3. And 0 degrees Celsius. One time, don't even wait. You convert it to Kelvin, 273. So let's do part A. They've asked us to find the new volume. So determine the new volume. So that's what we want to find. If it is heated to 27 degrees Celsius, so now our new temperature is 27 degrees Celsius, which will give us 300 Kelvin. And the pressure rises to 60 kilopascals. 60 kilopascals is 60 by 10 to the 3. So what they've asked us to find here is V2. So let's open up our question formula. P1 V1 over T1 is equal to P2 V2 over T2. See why I personally, again, I would go and manipulate the formula to make V2 the subject of formula. So what you do, you cross multiply and divide where you need to. So I'm going to get V2 is equal to P1 V1 multiplied by T2. And you're going to get T1 multiplied by P2. So I can plug in all my values right now. Let me just get some space. Let's plug in our values and see what we get. You're all going to do the next one on your own. P1 is 50,000. V1, 0.0045. T2, 300. Put over divide sign. T1, 273. P2, 60,000. And if you work that out, I don't think I worked that out as yet. Let's plug it in fast, the calculator. 50 to the 3 by 0.0045 by 300 equal, divide by 273, divide by 60 to the 3, and you're going to end up getting 4.12 by 10 to the minus 3 meters cubed. All right, so if you all want to go ahead and work out the whole P1, V1, T1 value, and then do a division and division and multiplication, go ahead. Whatever method works for you, you can go ahead and give it a try. So let me start you all up on the second part. So for part B, we still have our same P1, V1, and T1. So let's see what our P2, V2, and T2 will be. So they've asked us to determine the new temperature. So this is what we want to find. We want to work out, we want to work out the new temperature if the pressure increases by 20 kilopascals while the volume remains constant. So if the volume remains constant, I'm still going to have 0.0045 meters cube, and they said my pressure increases by 20,000. If my initial pressure was 50,000 and I increased by 20,000, what's my new pressure?
70,000.
70,000, very good. So you're going to end up getting 70 by 10 to the 3. So now I have all my terms. I have 1, 2, 3, 4, 5. I can find my 6th. Let's plug this into a formula. All right, then we'll do the working at the bottom. So for this one, let me use an X color pen so you don't get it mixed up. So for part B, P1 V1 over T1 is equal to P2 V2 over T2. But we can make life simple. What did we say is remaining constant in part B? What is constant in part B, Olio? Volume. And what did I say happen when you have a constant quantity that is constant? We'll make life easy.
You can take it out.
Just take it out. And we know what P1 is. Oops, sorry. We know what P1 is. We know what T1 is. We know what P2 is. Find T2. You all substitute. And let's give that a couple of minutes. Let me pause the recording so we can take like about 3 minutes. Take about 3 minutes. So for part B, if we were to put down all our terms nice and I will write over these P1, V1, T1 for each part. I won't just try to refer to it because you all can get it can get a little confusing. So P1 is 50,000, V1 is 0.0045, T1 is 273. They said that the volume remained constant, that the pressure increased by 20,000. So if it increased by 20,000, we have a new pressure of 70,000. And they asked us to find a new temperature. So my equation was P1 V1 over T1 is equal to P2 V2 over T2. And we said anytime a constant remains, a value remains constant, just take it out. Right? Just take it out. You're going to end up with P1 over T1 is equal to P2 over T2. I want to solve for T2, so I make it the subject of formula. I cross multiply and divide, so you're going to get P2 by T1 over P1. Plug in your values, and you're going to get 382.2 Kelvin. Let's try the last one on the screen. All right, last one for that point. So they've asked us, let me just pull this down to the end so at least you can use it. Copy. They've asked us to calculate the pressure if, so they've asked us to calculate the pressure if the volume decreases by 50% and the temperature falls to minus 50 degrees Celsius. So we already have our P1, V1, T1. You already have that written down, so I'm not going to write it over. All right, so let's see, we have our P2, our V2, and our T2. So let's see what they want. They want us to calculate the pressure if the volume decreases by 50%. So that means our new volume is going to be 50% of the original volume. What was the original volume? 0.0045. So you find half of that. 50% means half. So we divide by a half, and we're going to end up 0.00225. Check it on the calculators, make sure. And they said the temperature falls to minus 50 degrees Celsius. So we now have 50 degrees, minus 50 degrees Celsius. If we have to convert that to Kelvin, we're going to end up with 223 Kelvin. So they've asked us to calculate the new pressure. The original pressure was 50,000. I'm going to give you all the numbers to calculate. And the original temperature was 273. So let's just go back into our formula. Pulling back our formula on the screen. So you're going to have P1 V1 over T1 is equal to P2 V2 over T2. And they've asked us to find P2. If you go ahead and manipulate your formula, you're going to get P2 is equal to, you cross multiply here first. So you're going to get P1 V1 by T2. And then you cross multiply and divide, and you're going to end up with T1 by V2. So plug in your numbers. You have all of those numbers already. We have P1. All right. We have P1. We have V1. We have T1. We have V2. And we have T2. Plug in your values. Tell me what you get. Let's pause. And I can give you like 2 minutes to work it out. Aspect. So that's to get the solution for our question. If we had went and work out your P1, V1, T1, get your P2, V2, T2, manipulate your equation, and you get P2 is equal to P1, V1, T2 over T1 by V2. All you're doing here is manipulating your equation, no sort of big maths, cross multiply and divide. Plug in your values, and you will get 8.17 by 10 to the 4 pascals. Be really careful when you're doing your calculations. As I just said to the regular class, work out your numerator first. Write down your numerator value first. Work out your denominator value second, and then go and divide your two numbers by each other to get your answer. Your calculator does not follow BODMAS, so don't try to do a whole bunch of weird calculations if you're not too sure on how to use your calculator. But as you see, you can do it in one step. Yes.
How did you get the 10 to 4?
You count your decimal points.
Okay, miss. Thank you.
All right, you just count your decimal points to move to convert to the standard form. All right, and it is 3 o'clock, so we're going to wrap up there. But I'm going to post this up with a couple more questions in the Google Classroom. So the same handout, all I have to do is add a next question. You all can give it a try on your own. And then we're going to go on to some graph questions and some longer questions, some past paper questions. So folks, I will see you all on today's Wednesday, on Friday morning. So have a good day and I will see you then. Bye.